Hi, let's learn a little bit about electrostatics, which is totally related to electricity. Electrostatics is electricity at rest. It's not flowing. It involves electrical charges, the forces between them, and their behavior in materials. You'll understand the picture of this man with balloons attached to his head a little later. Okay, the atom, first you have to understand how it is actually formed and what it looks like. So electrons have a negative charge. They float around the outside of the atom. Protons have a positive charge. So here we have the protons in the middle. That makes up the nucleus. And the electrons with a negative charge around the outside. They float around, kind of like whipping around, okay? And then neutrons have no charge at all. Neutrons are like this purple part. They're in the nucleus also. So the nucleus is made of protons and neutrons. The electrons revolve around the nucleus. We just talked about that. Okay, so the electrons and protons, anything that is like charged, meaning they have the same charge, they push against each other, they repel each other. And opposite charges are actually attracted to each other. So you can see on the left, this is like a positive charge, they push against each other. Here's a positive and a negative. Oh, look, they like each other, they even have smiles. And then these two negative charges, they kind of stay away from each other. Okay. The concept of conservation of charge. So what happens is electrons are not created or destroyed, but are transformed from one material to another. I'm sure you learned earlier in physics that matter cannot be destroyed. It just changes into another matter. Okay, so if we know this, that these charges cannot be destroyed and you can't make them, they're always there, you can realize, oh, well, they must just kind of move around from material to material. And that's what happens. Electrons can actually move from one area to another. The protons are stuck in the nucleus, but the electrons can float around. So here we have a picture of this guy. He's got what we call a glass rod, and he's got a piece of fur. Fur is known to let go of its electrons very easily. So we use fur in our labs a lot with electricity. So here he's got the fur and he rubs it on the glass rod. And then what happens is that electrons from this fur they've been transferred. You can see there's a bunch of little negative little lines here. It's been transferred onto the rod. So they're transferred from the fur to the rod. So the rod becomes a negative charge. All right. We're going to go past these. Okay. So polarization, these, you can see with polarization, what happens is in this balloon, we have all the negative charges have lined up. And in the wall, this is a wall, we've got positive charges and negative charges. And what they've done is they have lined up together. The reason this happens is this balloon, if you rub it maybe against your hair has a lot of negative charges, just like that fur. and those negative charges can be transferred to that balloon. You rub the balloon on your body or on your hair, and then you put it up to the wall and it will stick, because what happens is these positive charges move towards this side of the wall and the negatives move towards this side. And since these two are attracted to each other, they stick to each other. So that's what makes this cartoon funny. We've got this dinosaur slash Godzilla type thing. It's rubbing the Goodyear blimp on him, getting a negative charge put onto it, and then he puts it up to the wall and it sticks to it, just like this would. That's what polarization is. It's making these positives all clump together and these negatives all clump together. All right, polarization. If you've ever had those little peanuts that get mailed to you, or little beans from the bean bag, or pieces of paper even, you could probably do this with pieces of paper. If the cat rolls around in it, all of those negative electrons from the cat's fur is going to attach to the little bits, and then they're going to stick to them. Okay, there are 3 ways to electrically charge an object. You can do it by friction, contact, and induction. And I'm going to quickly talk about each one. So by friction, what we mean is you're rubbing against something. So here, Garfield goes and scuffs his feet on the ground. And what he's doing is he's collecting the negative electrons from that carpet onto his feet. And then he goes up and he touches Odie, the dog, and boom, that electricity charge is transferred to him. So he is transferring and making this, charging himself up by friction, rubbing. Okay? That's what friction is, rubbing. And here's a funnier one. He rubs across the floor and then tries to eat his food and it blows up in his face. Okay, charging by contact. When a charged object is placed in contact with a neutral object, some charge will transfer to that neutral object. So here we have this cartoon. This top part, don't even read that. But the negative charges are being collected and rubbed and rubbed and rubbed, and then right when this guy touches that electrical charge there, it transfers into his body. Boom. There's a nice contact charging right there. Okay, fun fact. So these, looking back, this material in here that's been rolling around, in this dryer has a lot of negative charges on it. And to get rid of that static, what you can do is get bounce, some kind of static guard, and bounce and all those little dryer sheets. What happens is the dryer sheets are made of positive charged ions, and when you rub it against those negative ions, it equals them out. It makes them neutral. So then you don't have those little staticky, when you pull the sheets out of the dryer, it's not going to shock you when you pull them out, especially in the wintertime. Dry air makes it worse. Okay, charging by induction. So charging by induction means that the charging of an object without direct contact. So lightning is actually done by induction. The bottom of the cloud is negatively charged. We look here. The top of the cloud is positively charged. And what it does is it rolls across, it kind of moves across the land. And why this is happening, and all of a sudden we have these negatives here because they're being kind of pulled up because of these, these positives here are being pulled up from these negatives. They're attracted to each other, and then all of a sudden, kablam, the lightning strikes. Now, why this cloud moves all of its positives to one side and the negatives to the other at the bottom? Scientists, like you see here, it says, why is this charge separation happens? It's still unknown today. They're not quite sure why these clouds act this way as they are rolling across the ground. Okay? So a lightning is an electrical discharge between opposite charges.